So let's review what we've learned so far. We know that gravity is a force that pulls all objects to the center of the Earth. And to us, because we're so much smaller than the Earth, it seems like it's pulling everything down. But remember, down is just a term that's related to where we are. Gravity seems to pull things down towards our feet, but our feet are heading pointed towards the center of the Earth. We also learned that any two objects that have mass have gravity. You have mass, I have mass, but we don't have a lot of mass, so we have a very weak gravitational pull. But remember, if something has a lot of mass, it's going to have a lot of gravity. For example, Jupiter and the Sun, lots of mass, lots of gravity. But another thing that can affect how strong gravity is the distance between the objects. If we get the objects far from each other, then gravity's strength decreases, it goes down. But the closer you get to the objects, the greater the pull of gravity. Remember, we talked about satellites, how there's a sweet spot. If we get the satellite too far away from the Earth, then gravity is getting weaker and weaker between these two objects. The satellite could drift off. If we get the satellite too close to Earth, gravity's strength increases, and then the satellite could be pulled to the Earth and crash land. We also learned that gravity pulls on objects at the same rate or speed. And the reason that some objects fall slower than others on Earth is because something else besides gravity is interfering with it. In our case on Earth, it's usually the air. So if we drop the hammer and a feather on the Earth, the feather would land last because the air's push as it falls slows it down, and it doesn't really make much of a difference on the hammer. But if we repeated that on the moon, they'd land at the same time. There's no air on the moon. But on Earth, since there's air, as objects fall, they experience drag, or a pull, a push against them as they fall through the air. And depending on the shape of the object, that air resistance can have a bigger difference. Here's an acorn and an oak tree leaf, and you can see as they fall, gravity's pulling on both of these objects. But as they fall through the air, the shape of this leaf, there are more spots for the air to hit as it falls. A lot of the air on the acorn goes around it, and so the acorn lands first. Now what we want to do are look at some TCAP questions that you might see about gravity. Some of these are pretty easy. There are a few that are a little bit more tricky, and I want to show you how to navigate these. So let's look at this one. It says, which of the statements about Earth's gravity is true? Earth only pulls on objects that are touching the ground. Is that true? No. If I hold a marker up, it's not touching the ground, and I release it, gravity's going to pull it to the Earth. Let's look at B. Earth only pulls on objects with a lot of mass. No, that's not true either. A piece of lint will fall. A paperclip will fall. C. Earth can pull on objects without touching them. Does the Earth have to be touching the object for the gravity to be able to pull it to the Earth? No, it doesn't. So that's not true. The Earth doesn't have to be touching things, so C probably is the correct one. And then we have D. Earth can pull on some objects and push others away. Is that true? No. So the best answer here is C. Earth can pull on objects without touching them. It doesn't have to be touching in order for gravity to work. Now look at this one. Why does a ball thrown in the air fall back to Earth? F. It runs out of energy. G. Air resistance causes it to fall. H. Earth pulls it back down without touching it. Or J. It loses inertia. Now look at G. Is air pushing on the ball, resisting its motion as it moves through the air? Yes, it is, but is that what makes it fall? That does cause it to lose some of its energy, but does it make it fall down to the Earth? The correct answer on this one should be H. It pulls it back down without touching it. Some of the questions you'll see about gravity are just super easy. Look at this one. An apple falls to the ground because of magnetism, gravity, friction, or inertia. Which one? Yes, gravity. Now do this one and tell me what your answer is. Which of the following statements about gravity is true? A. Gravity causes objects to fall to Earth. B. Gravity only exists between objects that touch. C. Gravity is a type of matter. Or D, the same amount of gravity exists between all objects. Which one? If you chose A, gravity causes objects to fall to Earth, that's correct. Look at B. The objects don't have to touch in order for gravity to work. Now this is a great question. Let's do this one together. It says, Tessa conducted an experiment to see how long it takes different objects to drop to the floor. She dropped each object from the same height. Her results are shown in the table below. Now before we even look at the question, remember what I've taught you about how to answer these types of questions. You need to always make sure that you know what's going on in the experiment. Then be very familiar with the data. So let's look at the data chart. Here are the objects she dropped: an apple, a sheet of paper, a book, and a tennis ball. And it looks like she recorded their shapes. She also recorded their masses. And then look how she conducted this experiment. This is a similar one to the one we did in class. Remember how we had the objects race each other, but she didn't do that. What did she do? Yes, she must have started a stopwatch as they fell and recorded the time it took for them to land. And notice that two of them tied. Which two tied? Yes, the apple and the tennis ball tied. Now, the apple and the tennis ball, let's look at their masses. Apple is 150 grams, tennis ball 57 grams. So if it's mass that makes things fall faster, these two shouldn't have the same time. Why do you think they had the same time? What else could be causing them to land at the same time? Yes, they have similar shapes, don't they? Tennis ball is round, apple is pretty much round. So that would explain that. Which one took the longest to fall? Yes, look at the sheet of paper. 6 seconds. How can you explain that? Why would the sheet of paper fall much more slowly than the other objects? Yes, the shape of the sheet of paper. That big flat shape. Lots of spots for the air to hit on as it falls through the air. Now, let's look at the question. Now that we're very familiar with this chart. The question is, what can Tessa correctly conclude or figure out from her data? Let's see here. The mass of an object affects the rate at which it falls. Is that true? Is the mass affecting how fast it falls? Well, if that were true, these two with different masses should have different rates. And they had the same rate, 3 seconds and 3 seconds. So we can get rid of that. Let's look at G. The shape of an object affects the rate at which it falls. Is that true? Well, the ones with different shapes did fall at different rates, and we talked about this one being flat. That's a strong maybe. Let's look at H. Objects with more mass fall more quickly than objects with less mass. Again, go back to the tennis ball and the apple. If the apple has more mass, it should have fallen quicker, but it didn't. It tied with the tennis ball. And let's look at J. Objects that are round fall more slowly than objects that are flat. Is that true? Round, 3 seconds. Flat, 6 seconds. No, that was not true. So the best choice is G. The shape of the object affects how fast it falls. Look at this one. William dropped 2 sheets of paper from the same height at the same time. One sheet of paper was crumpled into a ball while the other was not. What happened? Now we did this in class. Let's look. The sheet that was not crumpled landed first. The sheet that was crumpled landed first. H, the 2 sheets of paper landed at the same time. Or J, the outcome cannot be predicted. What do you think? Yes, G, the sheet that was crumpled landed first. Why? Why does the crumpled one land faster than the flat one? Yes, the surface area. The flat one has a bigger surface, and there's more spots for the air to hit to slow it down. Let's look. Jonah kicked a ball into the air. Which explains why the ball eventually landed on the ground? Was it A, the friction caused by the ball moving through the air brought it back down? B, he didn't kick the ball hard enough to keep it in the air? C, gravity pulled the ball back to Earth? Or D, the revolution of Earth around the sun caused the Earth to catch up to the ball? What do you think? Yes, C. Gravity pulled the ball back to Earth. Look at A. There is friction from the air, but that's not what brings it down. That'll slow it down, but it doesn't bring it down to the Earth. And D is that's just good stuff right there. Let's do one more. Which of the following is true about a raindrop and a large rock? F. The raindrop will fall to the ground faster than the large rock. G. The large rock will fall to the ground faster than the raindrop. H. Both the raindrop and large rock will fall to the ground at the same rate. Or J. The raindrop will condense as it falls, but the rock will not change. Which one? Yes, you should have chosen H. The raindrop and the large rock will fall to the ground at the same time. Even though the large rock has more surface area than the raindrop, the mass of the rock, that extra surface area is not really going to be able to slow it down that much. So they would land and fall at the same time. Now, go to the TCAP practice section in your scientist notebook, and we're going to be numbering 1 through 15. There are 3 different SPIs on this, so the first section will be 1 through 6. That's SPI 12.1. So draw a divider line between 6 and 7. And then 7 through 10 is SPI 12.2. So draw a divider line after number 10. And then 11 through 15 is 12.3. Then write down the page numbers. It's pages 61 through 64.